Modern-day particle physics provides a thorough description of the fundamental building blocks of the universe, all laid out in the Standard Model. It explains all matter and radiation as being composed of infinitesimally small bits or particles. But while it can seem as though almost all major developments in the field have come in the past century or so, how far back does the knowledge really go? Today, it is knowledge that has inspired a plethora of advancements in technology, from the treatment of cancer to the development of computers and to the establishment of the World Wide Web. All are tied together by the Standard Model. It arguably starts in 1827, when the Scottish scientist Robert Brown first found observational evidence of atoms. Next came proof of the electron, first observed by J.J. Thomson in 1897. Today we know that all particles come in one of two kinds: fermions, which make up matter, and bosons, which act as carriers for the forces of nature. There were then various and crucial developments in the 19th century as we first began to properly observe particles. But the real history goes back much further still. In fact, the overall concept of a fundamental particle stretches way further back in time to around 2,500 years ago or more. When we talk of ancient civilizations, this can mean any culture from the Sumerians of Mesopotamia in 4000 BCE to the Roman Empire falling in the 5th and 6th centuries AD. And these iconic vital groups did invariably have a strong grasp on basic science. Perhaps none more so, however, than the ancient Greeks. By the 3rd century BCE, the Greeks already possessed an impressive knowledge of astronomy. They knew the Earth was spherical and had managed to measure its circumference to a more than reasonable degree of accuracy. Aristarchus of Samos was the first to theorize a heliocentric solar system, and he managed to approximate the distance of the Sun and Moon from the Earth as well. Remarkably, he did this by simply measuring the size of the Earth's shadow on the Moon during a solar eclipse. The Greeks also had basic chemistry. Numerous early philosophers, before even the later time of Socrates, mused that the universe must be made up of basic elements. Specifically, it was a figure known as Empedocles who proposed the 4 popular classical elements: water, earth, air, and fire. Back then, this was essentially a way to characterize materials based on their physical properties. What we now know more broadly as liquids were made up of water, solids from earth, gases from air, and finally, the fire today doubles up as plasma. The Greeks then believed that these basic elements could be combined to make compounds, and that everything on Earth was made up of a combination of these elements and compounds. Alongside this, they realized even then that it was possible to transition between elements. Clearly, it isn't a stretch to say that these ideas virtually are basic chemistry to modern minds. That philosophers such as Empedocles came up with principles that are still fundamental to science. We also know that the Greeks were adept mathematicians. Pythagoras created the first ever school of mathematics in the 6th century BCE. And of course, his theorem describing the geometry of a triangle is still used more than 2,500 years later. Another product of Greek math was the book The Elements, published by Euclid, who's frequently hailed as the father of geometry. Euclid's work provided a thorough description of geometry and managed the impressive feat of never really being surpassed until the 19th century. The roots of mathematics can be traced even further back, though, to ancient Egypt and Babylonia. Unfortunately, there's a lack of sources remaining to show exactly what the Egyptians did, but there do still exist approximately 400 clay tablets from Babylonia which reveal that they well understood fractions, algebra, and geometry. To some degree, what we now know as particle physics is an amalgamation of chemistry, math, geometry, etc., and all born out of the distant past. Easily the closest specific model to current thinking, though, was atomism. Put forward by Greece's Leucippus, it was a theory which stated that the universe is composed of fundamental, invisible components named atoms. It was then later that Leucippus's disciple, Democritus, formalized the theory further, stating that there was infinitely many atoms with infinitely many variations. This ranks as one of the earliest attempts to show that reality is made up of more than what we see at the macro level. Instead, the atomists, as they were called, hypothesized the larger world of nature to consist entirely of 2 base components, atoms and the void. They believed that various different arrangements or clusters of atoms were what created all substances in the real world. Cleverly, at its heart, it was a model built on intuition, too. The key early observation was that it isn't possible to divide a piece of matter infinitely. if you keep breaking something apart again and again and again, then eventually you must get to something so small that it cannot be broken further. And while we now know that there are lower levels to split to, for the atomists, that unbreakable something was the atom. What's doubly interesting, however, is that atomism didn't only arise in Greece. Indian philosophers also honed their own game-changing ideas that were arguably identical, at the same time or perhaps even before the Greeks did. The roots of Indian atomism lie in the 8th century BCE and with one particular sage named Aruni, who it said proposed that there are particles too small to be seen that form together into the substances and objects of experience. Not much later, an Indian natural philosopher formalized this idea. Historians estimate he lived in the 6th century BCE, and his name, Kanada, literally translates to atom eater. Kanada stated that the universe is made up of matter, which can be divided repeatedly until reaching a stage where no division is possible. This indivisible element he named Paramanu, and is essentially an atom. Alongside this, he suggested that Paramanu, or atoms, had an inherent urge to combine with one another, and that they should all be spherical. Kanada went on to form the first ever Indian school of natural philosophy, the Vaisheshika school, which later developed theories on the ways in which Paramanu combine into larger and more complicated objects. From the very beginning, though, the parallels between his ideas and modern particle physics are clear. It's perhaps pretty mind-blowing that philosophers in two completely separate parts of the world thousands of years ago would independently conceive of essentially the same theory for atoms. It's then also pretty incredible that the observational evidence for both wouldn't come until centuries later with the great thinkers in Europe in the 1800s. All of that said, however, while atomism is a remarkable philosophy, it's not as though it's identical to today's principles, which have been greatly updated and improved. The major change we benefit from now is the presence of technology, which again has made it possible to observe what we could only previously theorize at. Alongside this, all fields of science achieved significant development in the centuries leading up to the Industrial Revolution, to the benefit of almost all disciplines. For example, ancient civilizations were never lucky enough to have theories like Newton's theory of gravity or his formalism of calculus guiding what they knew. The establishment of the periodic table also has its roots in the Industrial Revolution, which helped us to greatly understand the link between element properties and their atomic weight. The general scientific method, a repeating cycle of observation, hypothesis, experimentation, and verification, wasn't at all developed in ancient times either, since it was initially pioneered by one Ibn al-Haytham during the Islamic Golden Age in the 10th century AD. The background to science has changed beyond all recognition then, but perhaps that only highlights just how impressive those earliest minds were. Yes, our knowledge and grasp of particle physics has skyrocketed in recent decades, and is now far beyond the wildest dreams of any ancient philosopher. But those civilizations of the past were never living in the dark. It was they that provided the foundations, at a time thousands of years before their ideas could be rigorously tested. If the genius philosophers of old could see us now, would they feel pride, or satisfaction at least, that what they felt to be true is now known to be fact? Because that's how ancient civilizations did know about particle